Cerbos Hub, how it works. Hi, I'm Alex from Cerbos, and today we're going to look at how you can use Cerbos to implement fine-grained authorization across your application architecture. So it all starts out with putting fine-grained policy decision points across your stack in different points of the architecture. If we begin on the client-side applications, you might have AI agents, you might have MCP clients, you might have web applications, mobile apps, IoT devices. All these applications themselves can actually have permissions baked into it. So you can take an embedded policyable decision point and put it inside of these client applications. You can do that for kind of presentational types of permissions, where you want to show and hide different menu items or form elements or page components based on the user's role or policy behind that. Those clients will then make requests off to your backend. Now, probably the first thing they're going to be doing is authenticating those users. So this is where your IDP gets involved, your identity provider. You can deploy a Cerbos policy decision point alongside your identity provider and use it during the token exchange and token issuance process to actually determine via policy which roles, scopes, claims, etc. should go inside of that token. So now you've got a token, you've given it to the client is now using that in the requests that come to your backend. Now you might have a traditional API gateway, maybe you're deploying an MCP server. In both those environments, you can deploy a PDP alongside of those and use policy to control what happens and is allowed through those gateways or servers. So inside of an API gateway, you can do route-based authorization based on headers and paths and HTTP payload. Inside of an MCP server, you can use policy to determine which tools should be enabled based on that user's identity. Once that user's through the gateway or through those initial servers, you then end up with your backend applications. You might have microservices, you might have legacy applications, you might have batch processes that are doing actions on behalf of the user. Next, alongside each of these systems, you can deploy a PDP and have those systems check their permissions and check their access inside of that local PDP running as a sidecar, where you can say this user is trying to do this permission, trying to do this action on this resource inside of the system to determine whether the action should be allowed or not, and have a policy-driven approach to that. So that can hook into your microservices in Go, TypeScript, Java, Go, whatever language you're using. You can be putting it as a proxy alongside your applications for legacy applications to do path-based or route-based filtering within inside of legacy systems to give you some level of visibility and observability of what's going on inside of those legacy systems. All those batch jobs or those other systems, maybe you have training jobs running somewhere, can also go and check permissions locally to determine whether an action should be done or not inside of one of those ephemeral jobs. You can also push authorization down to the backend. So you have databases, you have vector stores. You can use Cerbos as a query plan to actually do dynamic filtering of those records that come out of a database query or come out of a vector store to take a policy-based approach for determining access control of what records and what resources should be available back from the system. Now, all these components can typically be running inside of a service mesh. You might have heard of Istio, Linkerd, these kind of technologies. You can use Cerbos to do authorization and service-to-service authorization calls. So should service A be able to call service B on behalf of this particular upstream user, you can use policy and Cerbos' integrations at the service mesh layer to determine whether those access should be allowed or not. So now you have your authorization decisions being made across all these different points inside of the system. How do you manage and how do you ensure that all your policies are deployed uniformly across all these different touch points and integration points? And this is where Cerbos Hub comes in. So Cerbos Hub is a policy administration point. Within it, you have an IDE for managing policies, you have audit logs, you have metrics, and most importantly, you have a CI/CD pipeline that manages the rollout and update of policies across your both front end through the embedded policy updates, but also policy updates going to all those PDPs running across all your different backend applications. Two key components as part of the CI/CD pipeline inside of Cerbos Hub are policy stores and deployments. Think of policy stores as containers or buckets or folders of policy definitions, and these can be broken apart by teams or products or features or capabilities. You can even start overlaying tenant-based policies or customized policies per customer in these different policy stores. Then through a deployment, you can set up different environments, production, QA, staging, etc., which take those policy stores or a set of policy stores and combine those policies together. During the CI process, the policy stores get merged, any tests that are defined will run, and only if all those tests pass, will Cerbos Hub coordinate the rollout of all those policy updates to all those PDPs. All those PDPs will receive those policy updates, and every check each of those PDPs makes will return back an audit log to the policy administration point. So inside of Cerbos Hub, as part of the audit capabilities, you have that audit decision log, which tells you at this time, this user tried to do this action, this resource, and it was allowed or denied by this particular version of this particular policy for that full end-to-end visibility. But how do you get those audit logs? How do you get those policies into Cerbos Hub? Cerbos Hub exposes a few different mechanisms for loading policies in. You can do a native integration with GitHub, or you connect to GitLab or a Bitbucket or Azure DevOps bucket into Cerbos Hub, and it will pull those policies in. You can integrate Cerbos as a CI step process. So if you're using Circle CI or BuildKite or GitHub Actions, you can actually push policies as part of your own internal build process up to Cerbos Hub into one of those policy stores. And we also have CLI tooling, so you can run it locally or even upload it in the browser. So whenever one of those updates comes in and updates one of those policy stores, any of the linked deployments will get triggered to do a build. So say your platform policies are updated, all your deployments that are loading in the platform policies, which might be your production and QA environments, will trigger a build. It'll pull together all those policies, run a compilation, run all the tests, and then distribute all those policy updates to your different environments. The final piece of the puzzle is how you do dynamic policies, or how do you do per-tenant customizations of policies. So in this example, we have a managing user administration service inside of our architecture. And this could be a part of your application where users can go and create and define roles. They can tick which actions should be allowed. They can add conditions on those actions as well. And then your backend application can actually send a policy update programmatically to Cerbos Hub. So this policy updates line here is actually using the API that Cerbos Hub exposes with our native SDKs for most languages to go and create a new policy. And in this case, it might be writing that policy to, say, the tenant A store. And the same process as before will run, where that will trigger a build, a deployment. All the tests will pass, and then the latest policies will get pushed out to all those PDPs that we see running inside of the architecture, allowing you to have this end user managed way of defining policies and programmatically controlling policy updates across the stack. So as a whole, Cerbos Hub is that core control plane that manages all these policy decision points across your architecture for that consistent, fine-grained, real-time contextual authorization, bringing security and observability into your entire application stack.